2002 AP Calculus AB FRQ question from B log 6. Ship A is traveling due west towards the lighthouse rock at a speed of 15 kilometers per hour. Ship B is traveling due north away from the lighthouse rock at a speed of 30 kilometers per hour. Let X be the distance between ship A and the lighthouse at time T, and let Y be the distance between ship B and the lighthouse at time T, as shown in the figure below.
There's no way that can be right!
Part A says, find the distance in kilometers between ship A and ship B when x equals 4 kilometers and y equals 3 kilometers. Ship A, the lighthouse, and ship B form a triangle. X is representative of the distance ship A is from the lighthouse, which is 4 kilometers, and y represents the distance of ship B from the lighthouse, which is 3 kilometers. We're trying to find R, which is the distance between ship B and ship A. To do this, we're going to use the Pythagorean theorem, which is x squared plus y squared equals r squared. We plug in our values and we have 4 squared plus 3 squared equals r squared. 16 plus 9 is equal to 25, and take the square root of that and you get 5. So the answer is 5 kilometers.
Okay, part B. Find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 kilometers and y equals 3 kilometers. Alright, so here's part B. What you want to start with is we bring back our Pythagorean theorem that we used in part A. So r squared equals x squared plus y squared. Now, we're looking for the rate of change between ship B and ship A, which is our dr over dt. So what we can do is we take the derivative of each thing, so we take a derivative of r squared, we get 2r, 2x, and 2y. And you pair each with its rate of change, so we get 2r dr over dt equals 2x dx over dt plus 2y dy over dt. So first step is we'll go ahead and just take out this 2 because everything has one, so we can just wipe that out. And then we're left with r dr over dt equals x dx over dt plus y dy over dt. And now, here's our base equation. All we're going to do is just take our values that we have and just plug them in. So for r, we got 5. So we end up with 5 dr over dt, because that's what we're trying to find. We set that equal to x, which is 4, times dx over dt, which it's going to be negative 15 because the ship is moving towards the lighthouse. Notice it's going this direction, so it says 15 kilometers per hour, which is how fast it's moving, but because of its direction, we make it negative. So we have that plus y dy over dt, so we get 3 and 10. Now what we can do is we'll go ahead, take this side divided by 5, divide this side by 5. We're left with this. We get dr over dt equals 4 times negative 15 plus 3 times 10 over 5. You work all this out, and that's going to give you that your dr over dt is equal to negative 6 kilometers per hour.
Oh yeah!
Part 2 reads, let theta be the angle shown in the figure right here. Find the rate of change of theta in radians per hour when x equals 4 kilometers and y equals 3 kilometers. Since we're finding the measure of the angle in terms of x and y, we're going to use tangent of theta, which is y over x. And then we're going to use the quotient rule to find the rate of change of theta.
Okay, so now, the rest of part C, it's similar to what we had to do in B, where we have our equation, and we then need to find the rate of change of our variable theta. So, here's our equation right here. We get tangent theta equals y over x. So we're going to go ahead and take our derivatives of both sides in terms of their rates of change, and you end up with secant squared theta equals d theta over dt, which then equals this right here, dy over dtx minus dx over dty over x squared. And like Deepak was saying, that's our quotient rule, which basically means you take the derivative of the top times the bottom, dy over dt times x, minus the derivative of the bottom times the top, dx over dt times y, and then all of that over the bottom squared, x squared. So we go back over here, and here's our quotient rule, and here's the left side. Now secant squared theta, we get that because we take our derivative of our tan, which gives you secant squared theta. So now, we're going to do all this in terms of our variables again. So we have x equals 4, y equals 3, and our secant theta, which is going to be 4/5, which is going to go here. And we do that because we get 4 over 5 because we have r is 5, and here's our 4. So now, we plug in all our values, and you end up with d theta over dt equals 16/25 times all of our quotient rule here, which is 10 times 4, plug in our variables, minus negative 15 times 3, and remember it's negative 15 because the ship is moving in the opposite direction. All that over 16, which is our x squared. And you should go ahead and you multiply all these out, and you're going to end up with 17/5 radians per hour.